Okay, let us talk about flat mirrors. So, I have been given a flat mirror, and suppose I put an object here, call it O. The perpendicular distance of the object from the mirror, this straight line is the mirror, call it M. So, this perpendicular distance, call it P, will be called as the object distance. So, P is my object distance. Now, if you place some observer here who will look at the image of the object, he will find that the rays goes like this and get reflected. Or if it hits here, it will get reflected like this. And if you trace back the rays back, they seem to be coming from a point, call it I. This location I is called image point, and O was my object point, and the distance, call it Q, will be called image distance. So this is a terminology. I have a mirror here. This is my mirror. This is the mirror. And I have an object here. And from the object to the mirror, this perpendicular distance P, I call as object distance. And if I put some observer here, he will find that the rays, they are coming from this location I, which is called the image point. O was my object point, and the distance of the image point to the mirror, this perpendicular distance, will be called as the image distance. Now, given an image, the images are formed when either the ray of light actually intersect or they seem to intersect. Basically, images are formed at the location where the rays of light actually diverge from, or at the point where they appear to diverge. So in this case, the rays of light, they appear to diverge from point I. So I is the image point. So the image has been formed here because the rays of light appear to diverge from here, from this point. In some cases, they actually diverge from. So that basically separates the real versus virtual image. So in the case of real image, the light rays actually intersect at the image point and they diverge from there. And while for the virtual image, they do not intersect, but they seem to diverge. So in this case, the light rays, they actually seem to diverge. They do not actually intersect, because you can see they seem to diverge like this from this point I. So in the case of flat mirrors, I get a virtual image, but there are some cases where you can get real image. And also the real image can be obtained on a screen, but the virtual image can't be obtained on a screen. Now, to get the position of image where the image is formed, you just need two rays, because you just need two lines to get the intersection and get a point. So at the intersection point normally the image is formed, because at this point the rays of light can seem to diverge, or from where the rays of light seem to diverge, or they actually diverge. So this is about flat mirrors. The location of object, the location of image, object distance, image distance, image point, object point, and real versus virtual image. Okay, now let us talk about this concept called lateral magnification. So given an object, so suppose this is your flat mirror, this is my flat mirror. If I place an object in front of it of some height h, I will get height of the image at this point, h dash or something. I don't know what's the value of h dash. And this height I will call object height. Whereas h dash will be called image height. So it's quite intuitive, like the height of the object will be called the object height, while the height of the image will be called the image height. And when we talk about lateral magnification, it's basically the ratio of image height to the object height. So lateral magnification M is defined as, this is the symbol of defined as, image height divided by object height. So it is h dash by h in this case. And if we analyze properly, like what's the lateral magnification in the case of flat mirror, we should look for the geometry. So let us try to analyze lateral magnification for flat mirror. Okay. So this is my mirror. So it's a curve. This is my mirror. Call it M. And in front of the mirror, call it some line. This is a line. Some axis, some line just right here. And I place an object here. Call this point O and this point Q. So this point is Q, this point is O. Now when I place the object, its image will be formed. So the rays of light go like this and come back. And basically it seems to come back from behind. So it seems to come back from behind. We just need two rays of light to get the image. So we draw another ray. And it gets reflected. So if this angle is theta, this angle will be also theta, that you know for high school physics. And it seems to come from somewhere here. And I get the intersection point here. So this is where I get this is the place where I get the tip. So I get the image like this. If you draw all possible lines and so on, you will get image like this. And if this is H, call this H dash. Call this point as Q dash. This is O dash. Call this A, and this point is B. Now let us try to analyze this triangle and this triangle. Means triangle QBA and Q dash BA. So if you look at these two triangles, this side is common. This angle is 90 degree in both cases, and also this angle will be equal uh, because I know that this angle will be equal to this angle, and how should I say that? So this is theta, so this will be also theta. So this angle will be 90 minus theta, and this angle will be also 90 minus theta. So this angle is equal to this angle, this angle is equal to this angle, and this side is common. So basically by angle side angle congruency, I can say that this triangle is congruent to this triangle. So from here, if you like further extend the logic, you can similarly do for this triangle and this triangle, and come up with the conclusion that h should be equal to h dash, and the distance QB, should be equal to the distance Q dash B. So basically the object distance is same as the image distance that we get. We get object distance equal to image distance in the case of flat mirrors, and height of the object is same as the height of the image. So h is same as h prime. That basically means the lateral magnification is I should not use this symbol again. So the lateral magnification is h by h prime, which is nothing but h by h equal to 1. So for the flat mirror, I get lateral magnification equal to 1. And also the image is formed at the same distance behind the mirror as it was in front of the object, in front of the mirror. So object distance is same as the image distance. Also, you can see that when you are standing in front of a mirror, you find some kind of reversal. Like if this is the mirror, and if a person is standing here, suppose Golu is standing here, and if Golu moves his right hand, the image moves the left hand, and if Golu moves the left hand, the image moves the right hand. So Golu will say that there is some kind of reversal, and he will say that my left hand becomes right hand in the mirror and the right hand becomes the left hand. So he can say that there is left-right reversal in case of flat mirror, But this thing is actually not totally correct. So this statement that flat mirrors give us left-right reversal is actually a myth. Not myth, it's not 100% correct. So if you stand in front of a mirror, and suppose what I do that I sleep in front of the mirror. So that the position where my left hand was, I place my head, and where my right hand was, I place my legs. So if I move my legs, I won't see the my head moving in this case. So actually, if I move my right leg, here left leg will move, but not the left-right reversal happens. So in fact, it's not left-right reversal. It's something called front-back reversal. So in the case of flat mirrors, what we get is front-back reversal and not left-right reversal. You can look at Google search Google for front back reversal and you will know more about these all. So these are the key points about a flat mirror. So in a flat mirror, what we find that we find that the object distance is same as the image distance that you can find here. The object distance is same as the image distance. QB is equal to Q prime. Also, the image is virtual, and we call it virtual because virtual image is formed when light rays do not intersect. They just seem to diverge from that point. And here in the case of flat mirror, we see that the light rays they seem to diverge from point I. They do not really intersect. So the image formed by a flat mirror is actually a virtual image. So the image is virtual. Also, the image is upright. That basically means that if a person is standing in front of the mirror, actually he will find his image also standing. It will not happen that he is standing like this and here he gets this kind of image. This does not happen. So the image is upright. Image is upright. Also, it's unmagnified. That basically means that the magnification equal to 1 because h is equal to h prime. And also we find there is something called front back reversal. So we don't normally people think of this as left right reversal, which is not 100% correct. What we actually get is front back reversal. So these are the key concepts about flat mirror, which you need to tackle exams like IIT JEE or say All India pre-medical test and similar exams. Now let us I will give you an exercise which you should try to solve and apply this by applying these concepts. So I have a mirror M1 and there is another mirror, call it M2. Both of these mirrors are actually flat mirrors. Both of these mirrors are flat. And the angle between the mirrors is theta. So this angle is theta. Now, at the angle bisector, say at a distance d, at the angle bisector means at the angle, this angle being theta by 2, I place an object O. Now, the question is that what are the location of images? The first question should be how many images? How many images that will be formed? And what will the location of images? You should try to solve this problem for theta equal to pi by 2 and theta equal to pi. So you need to apply these concepts like in the case of flat mirrors. In the case of flat mirrors, I get object distance equal to image distance. Image is virtual, it's upright, unmagnified, and there is something called front back reversal. So using these concepts, try to find here how many images will be formed, what will be the location of the images, and try to do it for theta equal to pi by 2 and theta equal to pi.